We discussed question 3 of N-level mathematics paper 5, probability and statistics 1 in May or June of year 2020. A company produces small boxes of sweets that contain 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from a box, and we need to draw up the probability distribution table for the number of jellies that Jamil chooses. So we are going to set the number of jellies that Jamil chooses to be X, which is the random variable that we are interested in. Now he chose 3 sweets at random. The number of jellies that he could have chosen is either 0, 1, 2, and 3. So these are the possible values of X. And to draw up a probability distribution table, we just need the values of X and the probability associated with each X value. So X is either 0, 1, 2, or 3. And then we have P of X here, which we need to find. So let's say when X is 0, we have P of 0. Before that, in that box, there are 5 jellies and 3 chocolates. In total, there are 8 sweets in a box. Probability 0. 0 means we are looking at the probability that he chose no jellies. There are 3 chocolates that he chose. So he chose 3 chocolates, and the first chocolate has a probability of 3 out of 8 of being chosen. Once he chose a chocolate, then there are only 7 left, and there are only 2 chocolates left. And after that, there are 6 sweets left in the box, and there is only 1 chocolate left, and that is 1 out of 56. So P of 0 is 1 out of 56. To find P of 1, P of 1 is the probability that he chose 1 jelly. So probability of choosing a jelly, the first one could be a jelly, or you could have the second one that is a jelly, or you could have a third one that is a jelly. So you could have all these 3 possibilities. All these will have the same probability. You just have 3 times the probability of getting a jelly, a chocolate, and a chocolate. So we have 3 times getting a jelly. You have 5 out of 8. And once you have chosen the first one, there are 7 left. And once you have chosen one, there are 6 left. There are 3 chocolates, and then once you have taken out a chocolate, there are only 2 left. So from here, that 3 and 2 and the 6 can cancel to be a 1. We have 15 out of 56. Now, it is easier if we keep the denominator to be 56. So the third case is the probability X equals 2. Probability X equals 2, we are looking at jelly, jelly, chocolate. Same as the case where there is only 1 jelly. Your jelly, chocolate, chocolate, there are 3 possibilities. Jelly, jelly, chocolate here has 3 possibilities. So we have 3 times a jelly. The first jelly has a probability of 5 out of 8. And then you have 7 left and 6 left in the box. The second is a jelly. You have chosen 1 jelly. There are 4 left in the box. And the third one is a chocolate. There are 3 chocolates in the box. So that becomes a 2, and that becomes a 3, that becomes a 1. And this will give us 15, 30 over 56. So we have 30 over 56 here. Probability of choosing 3 jellies. So we have P of 3, you have jelly, jelly, jelly. There's only one outcome of getting 3 jellies. Initially, there are 8 sweets, 7 and 6. So there are 5 jellies in the box initially. After 1 is chosen, you have 4, and after that, you have 3. So that becomes a 2, the 6 gets cancelled off. That is 10 out of 56. We have 10 out of 56. Now to check that your answer is correct, you add all these up. 30, 45, 55, 56 out of 56. Total probability must be 1. So if the total probability must be 1, then this probability distribution table must be correct. For the third case here, instead of computing this probability, we could always, for the third case here, P of 3 here can be 1 minus the rest of them. You can subtract 1 out of 56, subtract 15 out of 56, and we can subtract 30 out of 56, and we will still get 10 out of 56. This is another way to find the last probability. These probability values must add to 1. The second part. The company also produces large boxes of sweets. For any large box, the probability that it contains more jellies than chocolates is 0.64. 10 large boxes are chosen at random. So in any one box, the probability of having more jelly than chocolate, this is 0.64. And 10 large boxes are chosen at random. Find the probability that no more than 7 of these boxes contains more jellies than chocolate. So for this case, we are looking at the random variable x here, which is the number of boxes out of 10 that contains more jellies than chocolates. So probability of a box that contains more jellies than chocolate is the probability of success that we are looking at. And we say that the probability of success is 0.64. We are looking at the number of boxes out of 10. The total number of trials is 10. And from here, whether a box has more jellies than chocolate or not is independent from any other boxes. We say that X follows a binomial distribution with n equals 10 and probability of success equals 0.64. Probability no more than 7. So no more than 7, X here must be less than or equals to 7. No more than 7, the minimum must be 7. Now, to find probability X less than or equals to 7, you could have probability X equals 0 plus probability X equals 1, and then you add up to probability X equals X less than or equals to 7. If you do that, by the time you are done computing all this, your exam is over already. Use the complement rule. Total probability is 1. So this is 1 minus probability X greater than or equals to 8. So that is 1 minus probability X equals 8 minus probability X equals 9 minus probability X equals 10. That would be faster than computing all that. For a binomial distribution, probability X equals R. This is given by NCR. p to the r, 1 minus p to the n minus r. That gives you the probability that x takes a value of r. So for this case, x equals 8, you have 10C8 and 0.64 to the 8. 1 minus 0.64, that is the probability of failure. We have 0.36. So we have 0.36 to the 2 minus 10C9, 0.64 to the 9, and 0.36 to the 1. And then you have 10C10, you have 0.64 to the 10, and 0.36 to the 0. That gives a 1, so you can just forget about that. And when you compute this, you should get a value of 0.759. So this should give you 0.759.